So you want to do something like find the values of x which satisfy minus x squared plus 2x plus 4 is greater than or equal to 1. Well, of course, this is a quadratic inequality. This is a graph, and we want to know where that graph is greater than or equal to 1. But when we deal with quadratics, often the best way forward is to get 0 on one side. So if we do that, all I've done is take away 1 from both sides. So this is just a rewrite of that. It's the very same. And then I can tidy this up. Plus 4 minus 1 is just plus 3. And this is the very same as that. It's just a rewrite. It's going to give us the same solutions, but it's easier to deal with because 0 is the x-axis. It's where y equals 0. In other words, the x-axis. So we can see that on a graph. It would have been more difficult here. And what this allows us to do also is to write this, which we've become used to seeing as something that we can factorize with. And through factorizing, we can detect where this graph goes through the x-axis where y equals 0. Now then, not a nice factorization if the x squared term is negative, but we can remedy that very quickly. If we multiply right through by minus 1, then that will have the effect of reversing all of the signs. So we'd have x squared minus 2x minus 3 equals 0. Of course, if we multiply the 0 on the right hand side by minus 1, we just get 0 back. This is something we can factorize. So we do our brackets. We know we've got x at the front of each bracket. We know we just want a factor pair for 3 that hopefully we can make the minus 2 out of, and we can, because if we have 1x and 3x, well, if we have plus 1x and minus 3x, we do get minus 2x, and then we just check that we can get the minus 3. Minus times a plus is a minus, and 3 times 1 is 3, so it works. Now then, if this bracket is going to be 0, equal to 0, then x must equal 3. And if this bracket is going to be equal to 0, then the x must equal minus 1. So what we've found there is very useful because it tells us where this graph crosses the x-axis. And I've graphed this. So that's the very graph, the n-shaped graph as we predicted, and it's going through, as we've also now predicted, the x-axis at minus 1 and 3. So where this graph that we're looking at is greater than or equal to 0, well, 0 is the x-axis. That's where y equals 0. So anything above the x-axis is greater than or equal to 0, or positive. And that part of the graph, of course, including where it equals 0, and anything where it's greater than 0 would be there. So we can go back and we can say that our initial question, we were asked to find the values of x which satisfy this, which we rewrote as this and will give us the same solutions. So where minus x squared plus 2x plus 3, in other words, this graph here, is greater than or equal to 0, is the bit that we put into green. Well, the solution to that is anything including minus 1 up to and including plus 3. So we'd write that like this. We'd put our x in the middle and we'd say where x is less than or equal to 3. So less than or equal to 3, because that's where the positive part of the graph is. Or, if we're reading out from the centre, greater than or equal to minus 1. Reading out from the centre, greater than or equal to minus 1. And we can see that that's the case on the graph again. It's between minus 1 here and then down to 3, where it's equal to 0 there, but anything before it, down to a minus 1, has always been greater than or equal to 0, or above the x-axis. So that would be our solution to this question. Find the values of x which satisfy minus x squared plus 2x plus 4 is greater than or equal to 1, or as we wrote it, minus x squared plus 2x plus 3 is greater than 0.